Hello everyone, we are glad to see you. I am Jirka and this is
Lenka.
And we are from the amazing Theatre of Chemistry. And today we would like to show you one small chemical wonder.
Let's start with this one cylinder filled with unpleasantly smelling gas, ammonia. Ammonia would like to burn with the oxygen in the air, but it can't. It needs something to push it. And we have this thing. It is this green powder that is Jirka now heating. It has to be heated as much as possible. So how does it look like?
Yeah, I think we are ready. So can we please turn the lights down? Thank you, thank you. And I will now throw this green hot powder into the ammonia. And you shall see. Thank you, thank you. And you are seeing the burning of ammonia. It looks like fireflies flying everywhere. It's quite nice. And the green powder pushed the ammonia. It made it to burn. But if you look at the bottom of the cylinder, the green powder is still there. Yeah, thank you for the lights. The green powder is still there. And that's because the green powder is a catalyst. Catalysts are chemicals that enter some chemical reaction, then they make it happen or they make it go very fast, and then they will exit the chemical reaction unchanged.
Catalysts are really important for humans, and they help us make many wonderful things. For example, plastic bags, fuel for our car, or this ammonia, thanks to which we can have fertilizers and therefore our population.
Yeah, but how do these catalysts work? Well, we have one here, this one. This is a Czech coin. It's 10 Czech rounds. It's like 0.45 euros or 0.45 Swiss francs. It's the same thing now. That's not important. What is important, that it's made of copper. Yeah, if you could just show it how I'm hitting it. And it needs to be very hot. It needs to be very hot because the hotter the copper is, the more it will react. And I think we are also ready. So we need another flammable. This time we don't have ammonia, we have acetone. It would also like to burn, but it needs some catalyst to push it. So please bring out the catalyst. And see it now. You should start seeing these patches of copper and black and copper and black. They are changing there, they are switching places. Sometimes it's all black, sometimes it's all copper. And this is what catalysts do.
We would like to look at it, at the atoms, what they do. But they are too small, we can't see them. So we will show it on us. I am copper. As you see, my
her trousers, yeah.
Trousers are copper. And I will take oxygen from the air. This makes me black. And here comes acetone. He steals my oxygen. And I am lonely copper again. But don't worry. I can have another oxygen from the air. This makes me black again. So here comes another acetone, and he steals my oxygen. And I am a lonely copper again. But I can have another oxygen from the air, and I turn black again. And here comes another different acetone, and he steals my oxygen again. And as you can see, this can go round and round and round and round. I, as the catalyst, as a copper, could do it forever. But as we used all costumes for our acetone, we can go back to our reaction.
Yeah, as you can see, the coin is still here. It didn't change color, it's still copper. It didn't change anything. But now we have the products of burning of acetone around us in the air. And that's what's so important and what's so great about catalysts. They are a great bargain. You just buy them once, and you can reuse them again and again and again and again, theoretically forever. Just buy it once, and it holds forever. Quick questions. Quick question. Who does here own a car? Please raise your hands. Great, great. I think it's like 15 of you. So 15 people that are sitting right here have a catalyst, own a catalyst. Because in your car, there is a catalytic converter. It converts the dangerous waste products into less dangerous waste products. It does it by containing a lot of precious metals like platinum. They are very great at catalyzing things, but they are also very expensive. So that's why often catalytic converters are stolen from the cars.
But not only cars, also something much cooler use catalyst. Rockets. Let's make some rocket fuel. The first thing we need is hydrogen peroxide. I have it here, and also I already put it in a flask. It would like to release oxygen, but once again, it needs something to push it. And I have it here. It's a catalyst. I put it on a spoon. Yeah, the right amount. Yeah, I think this is the right amount. And I can put it in the flask. So 3, 2, 1. I made oxygen, and I will show you that I have oxygen. I have this wooden stick, and I put it on fire. Please turn the lights off. Thank you. And when I put it inside the flask, it burns more. Because when you have more oxygen, you have bigger fire.
And that's what we need to... That's okay, thank you.
Thank you.
And that's exactly what we need for our rocket fuel. We need to burn it fast to go a long place. So we need the hydrogen peroxide, and we will use it for our rocket fuel. So we need hydrogen peroxide. I think just the right amount. And we will need something that likes to burn. And it's alcohol. Alcohol is very nicely flammable, so when we put them together, we can set it on fire. So. Yeah, and it's not so great. It's not terrible, but it's not so great. And that's because the oxygen is still trapped inside the hydrogen peroxide. We need to release it, again, using our catalyst. So. I will have our catalyst. Please hold it. Thank you.
The right amount.
Yeah, we need the right amount. We don't want to go to the Mars. We only go to the moon. So, the right amount. And please, let's start our rocket together. From 5, 4, 3, 2, 1, lift off.
Now you know how catalysts work. So go ahead and explore yourself some chemical wonders.
Safely, of course.
And thank you.
Thank you.